Howdy, my name is Seth Pugh, and today I will be demonstrating the like dissolves like property when dissolving a solid into a liquid. Now in order to do this, I will be dissolving 1 teaspoon of salt into 2 cups of water, and after 60 seconds I will be observing how well that solid dissolved in water. I will be doing the exact same thing with sand. Now, let's go ahead and see how salt dissolves. Here we have our 1 tablespoon of salt, along with our 2 cups of water in this bowl right here. So we're going to go ahead and take the 1 tablespoon, go ahead and put in our water here, and then we're going to probably just stir the bowl a little bit. Well, actually it'd probably work best if we use a little bit of a spoon. Go ahead and stir up the salt just a little bit in there, and we'll come back when it's 60 seconds. All right, after 60 seconds of the salt being inside the water here, we can see that we hardly see any salt left over, maybe just a little, but for the most part has been fully dissolved into the water. Now let's put 1 teaspoon of sand into a freshly new cups of water. All right, here we go. All right, and as we did with the salt, we're going to give it a stir for just a little bit. After 60 seconds, we can clearly see that there is quite a bit of sand left in our water. I don't think, if any did dissolve, it would have been very little, but we can clearly see that the majority did not dissolve and see a big difference between salt and sand in this experiment. Now let's go ahead and look at the chemical makeup of our 3 substances that we used in this experiment. So at the top here we have water, which is going to be made of H2O. And in the middle here we have oxygen, and oxygen has 2 lone pair electrons. Now in a molecular geometry, those 2 lone pair electrons are going to push down the hydrogens, making the dipole moments slightly more positive in the upward direction. Therefore, they don't completely equal each other out. It'll be considered a polar molecule. And now let's look at sand. So we can see in sand that both dipole moments are actually equaled out to each other, and so it would be nonpolar. Now with salt, this one's a little simpler than the other 2, just made up of NaCl. And because chlorine is more electronegative than sodium here, the dipole moment's just going to move to the chlorine side, making it polar. After examining these 3 substances, we can see that salt, which is polar, dissolves greatly into polar water, whereas sand does not dissolve greatly into water because sand is nonpolar. So polar dissolves in polar, and the nonpolar did not dissolve in the polar, proving the like dissolves in like principle.